Cool. So I wanted to go over the binary search progression. Did anyone give it a shot? I didn't hear anything on the Go channel. Did anybody get stuck on anything? Did anybody have any solutions they wanted to share? Any comments on the progression?
I was on vacation, so I plead the fifth here, but
No Go on vacation. Just take it easy.
And I have been totally swamped, so I still haven't plan on revisiting that.
Same here.
This afternoon.
Yeah, I'm sure that's going to be a common story, but we'll try to reduce the load coming up. I think what we'll do is we'll just have someone suggest a topic for a problem, and we can just do one single problem. And then if that problem's too hard, then we'll take a step back and try to figure out how to build up to it. So we'll try to do that with concurrency next, so that we can reduce the load on people if they want to, participate fully.
I think the only way to reduce the load is if you somehow start taking over some of the work that I've got assigned to me, but
Yep, I totally understand.
But with Go, we can parallelize it, right? As soon as we learn channels, we'll have less work.
Yeah, we're all Go routines. We're just working in parallel. The problem is coordinating. It's always a problem, but we'll figure it out. Hey, Robert, how are you doing?
Hey.
Okay, let's see here. So I'm going to try to run through these exercises, the ones that were remaining. I'm going to pull up the project here. Everyone see my screen okay? Give me a thumbs up. Cool. Let's see here. So we're going to, I have a solutions branch that should have everything we need. Make sure it's up to date on master first. Okay, so just to do a little quick recap of where we were last time, we had the middle index is the one that we implemented as a live coding exercise. So what we're doing here is we have a slice of things and we want to access the middle element. And that's going to be really important for binary search, because what we're doing is we're splitting the problem into smaller and smaller pieces until we get to this base case, which is that we've found the number that we're looking for. So this piece of the problem is just helping us figure out how to access the middle element. And we're basically dividing the number of elements in half and then accessing it and seeing what's in there. So we did that at the last meetup. And the next item, I'm just going to pull up the binary search progression here. The next thing is splitting the slice around that element. So we have this problem here, split slice Go. Actually, I'm going to pull it up on the left over here. So there's a lot of documentation here and very little code. And so that's kind of the gist of it. But I'm also going to pull up the test code so we can see what we're trying to do here. So under mechanics, and we've got split, what is it? Split slice underscore test. So what we're trying to do here is that we want these test cases to pass. So these are our test cases. We have a slice that is an input, and then we have an index that we want to split the slice around, and then we have what we expect the left side to be and what we expect the right side to be. So we're going to write the code to do this. And does anybody want to shout out, how we're going to do this, what the Go mechanism is that allows us to create multiple slices?
I guess before that I have a question.
Sure.
We're splitting the slice on the first index. Does that mean we're just discounting, like in that first one, we have 1, 2, and 3. 2 appears to just go away. Is that expected?
Yeah, so this is working backwards from a solution I have for the binary search. So in the binary search, what we're doing is we look at the middle element of the remaining slice, and we see, is this the number that we're looking for? And if it's so, like if we have 1, 2, 3, for example, and we're looking for 3, the first thing we're going to do is we're going to look at the middle. And if that middle is not what we want, then we're going to continue searching in the correct direction, either left or right, because this is a pre-sorted list of numbers. So if we know that the number that is in the middle is not what we want, then we can remove it from the set of things to search through. There's no point in continuing to include that in the left or right if we know it's not the value that we want. Does that make sense?
Yes, it does. Thank you.
Yeah, and just to give a further illustration, we don't want this because we already know that 2 is not what we want. And likewise, we don't want 2 to be included in this list because we already know that it's not the value that we want. So yeah, that's why we're doing it. There's other implementations that I've seen, and I think some of them they will include that value in the list because it doesn't really matter if you continue splitting it, from what I understand. But for this implementation, which I've seen work, we're gonna just exclude that middle element if it doesn't match. So let's see here. Let's go to the implementation code. So the thing that I'm looking for here is that we want to use the slice indexes to be able to specify, we want a subslice from here to there. So the way that we're going to do this is I'm going to do a real naive solution and see how that works. I'm going to just go down to the return statement down here. And what I'm going to do is just return S. So S is the input slice. We want to return the left-hand side. And we know we want to return the left-hand side because you can see right here, left is going to be the first parameter and right is going to be the second parameter. So what we want to do is we want to split this slice into the beginning of it all the way until the halfway point. So I'm going to get the length of the slice and I'm going to divide that by 2. And then I'm going to do the same thing here. Actually, I'm sorry, we have the middle index provided. So I'm going to put the middle index, and then I'm going to put the other side, the right side, and I'm going to do it on I to the end of the slice. So let's see what happens here when we try to run the test. And I'm going to use this piece right here. Let's see what happens. We get a fail here. So splitting 1, 2, 3 by index 1 yielded left 1 and right 2, 3. Right 2, 3 doesn't match desired 3. So this is the problem that we were just discussing, is that we want this to be exclusive of the middle index. We don't want that part of the bounds of this array. So there's too many things. Go ahead.
And is that panic below that, is that the same test?
That's the same test. I believe that's a different test case. So there's some edge case here where it's causing the whole thing to fail. Probably whenever I see something like this, it's either a nil pointer or it's out of bounds of the array is my guess. So since we're dealing with slices, this is probably an out of bounds error. And yeah, you can see here the panic gives a little more information. Slice bounds out of range. So we'll get to that edge case in just a second after we fix it the naive way. So we know that we want to split to the right of the index. So, and this is something that is important to note, is that in this index notation that you're looking at, where we have the number colon the end of the slice, what Go does is that the first index that you provide, so in this case 0, is inclusive of that range. So that means 0 index will be included in this slice, but the value that you provide on the right will not be included in that slice. So let's say I is 3, it's not going to go all the way up. It's not going to include the third element in the slice, in this subslice. What it's going to do is it's going to include the one before that. And this is handy if you want to use the length of a slice as the last parameter, because you don't have to worry about it being out of bounds, because we use zero-based indexing in Go. So we start counting at 0. So if the length of a slice is 3, the last index is not 3, it's going to be 2, right? Because we started counting at 0, so it's going to be 1 less. So this is handy for when you want to use the length of the slice to indicate the last element. You don't have to worry about it breaking in this slice notation. So that doesn't work though for the beginning here. So that's why we're not getting the test results we want. So what we're going to do here is we're going to just add a little handy +1. And then we're going to try again. See what happens. So 1, 2, 3, we got 1 and 3. That's what we wanted. But then let's see here, 1, 2, 3, 4, 5, 6 by index 2, which is this little guy right here, yielded 1, 2, and 4, 5, 6. That's also what we want. Splitting 1 by index 0 yielded a empty slice and then an empty slice, which I believe is also what we want. Oh, and actually, what I'm going to do is I'm going to pull up the test on the right side here in the browser just so we can see it at the same time. Okay, so splitting 1 by the middle index gives us nothing and nothing, which is this test case right here. That's what we expect, nil and nil, or empty and empty. And here's another thing that might be a little confusing. So a slice can be 2 different values if it's empty. It can be nil, and it can be an initialized value that just doesn't contain any elements. So that's a little confusing. A lot of times the idiomatic thing to do is just have nil represent an empty slice. And that way you don't have to worry about initializing anything, and everyone else respects that usually. That's the common pattern. And the reason why that works is because things like the length function, the len function, if you run that with a nil, like an uninitialized slice, it's going to return 0. It won't panic and say, oh, this thing isn't initialized, I can't figure out the length. It's actually able to tell you, oh, it's nil, that means a 0 length slice. So that's a common thing you'll see in code, is just not initializing the slice if it has nothing in it. So let's see here. We have a failure here on, this is exactly what I'm talking about here. We do is we have a check where we check literally the value, and if it's an initialized slice instead of nil, then it's failing. So what we can do is we can either modify the test so that it's more idiomatic, like I just said, or we can modify the implementation so that if a list is empty, we're going to return nil. And I'm just going to do that just so we can move forward fast. So what I'm going to do here is I'm going to go change these. And anybody have any questions so far about anything that I've been rambling about? If left equals, or if the length of left is equal to 0, then we're just going to set left to nil. And then if the length of right is equal to 0, then we're going to just set right to 0. Okay. And I think we'll just do a naked return, even though this is not usually advisable. We're talking about that last study session, but I'll do that just because it's a small function. It's easy. It's not too hard to read this. Okay, let's try running this again. We got an error here on line 29. Oh, I put 0 instead of nil. Okay, let's try that again.
So you were saying that an initialized slice will be either, or it's possible to treat it as nil or in the initialized state. Why are we not returning nil as well? can we return? Well, if I guess if we could return a slice, would it make sense for us to return a nil value instead of like an uninitialized or than an initialized slice?
So I'm trying to understand the question. So the slice is a reference value, so it's like a pointer, right? So it can either, when it's first initialized, it's going to have a 0 value. And actually, let me pull up the Go playground so we can see this in another area here. So if I have a function, or sorry, if I have a variable like x, which is a slice of ints, and it's uninitialized, and then I just print x, I get the empty. This is how it's the stringer function for a slice is just doing a pretty formatting for me. So it looks like it's an initialized value, right? Because I don't see nil here, but under the covers, it's really a nil value. If I try to print the pointer, I believe it will show us that it's nil. Let's try that. Yeah, so there's a 0, the 0 address representing nil. So when you do this,
would it matter if we return nil or an initialized like slice then?
Normally it doesn't matter, but in this specific test, it's checking for the actual pointer to the value to see that it's. Let me look at the test again. Pull that up. Get out of the way, Zoom. Zoom's getting in my way. All right, so in the test, what we're doing is we're checking that the left and the right, they match the values that we have in the test cases here. So for example, we say, I want nil here, I want nil here. So this equality test, this reflect.deep equal, it cares that the slice is exactly nil and not an initialized value that's empty. So this is just the way that this function works. If you were to use the length function, it wouldn't care if it's nil or uninitialized. So this is kind of an example of why we want our test to kind of reflect how we're actually going to be using the values returned. Because if we know that most people are not going to care if it's nil or an empty slice, then our test should really reflect that. So this is kind of a bad test, is essentially the problem. So it shouldn't matter if we return those two different types of values. Does that answer your question?
Yeah, and would it allow it right now based on the function signature?
Yeah, it would. So anytime you have a slice can be nil. So what you're returning is you're returning a nil value of type slice. So nils, the nil value is always typed, if that makes sense. So I think it's always typed. I was just reading an article about it. I'll try to dig that up. Let me pull up a follow-up item. Article about typed nils. So yeah, it matches the return value because that nil value is implied to be of type slice. Any other questions?
I have another question here. Why don't you use guard statement instead of assignment to nil?
Guard statement. So
go ahead.
What kind of guard statement would you suggest?
I would just check if s is nil, then return nil nil, and that's all.
That's a good idea. That's a good idea. Let's do that. That is much simpler. So if s is equal to one item or 0, right? So if length of s is less than or equal to 1, is it 1? No, it's has to be 0. So if length of s is equal to 0, return nil, nil. Let's try that. That continues to work. Yeah, so if you can identify a guard statement, that is definitely better because you're going to have, it's a simpler logic and it exits earlier. It's not going to trigger all that other logic and make things messy. So yeah, that's a good suggestion. I like that. The other thing we can also do is we can modify these test cases so that they're actually an uninitialized slice, which is simply, let's see here, it would just be this. So that's not nil. Like even though it's empty, it's not nil. But yeah, we have stuff working now, so we'll leave it there. Okay, so we have this edge case that's failing. Let's see here. So on the test case where we have an empty slice, it's getting a slice bounds out of range. So this is also a good situation where you want to have a guard statement to prevent the program from progressing if there's an issue. So does anyone want to chime in on what that guard statement would look like?
So if the length of S is 1, then return empty slice for the. No.
So in this case, the case that it's failing on is that the length is, actually, let me pull that up again. So the specific case is an empty slice. So the length isn't 1, it's going to be 0. And splitting by index 0 yielded yada, yada, yada. Oh, sorry, it was a different one. Slice bounds out of range for 2.
So this is the I+1 on the second return for the tail.
The I+1. Yeah, I believe so. So we're looking at, it'll tell us, let's see here, 2752. It's not that one. It's not this one because this one succeeds. It's this one. So we have a slice of one element. And then we say we want to split around the second index. There is no second index.
Okay, so if the index is greater than the length of the input.
Yeah, so the requirements that I glossed over, if we go look at them, it says here, if the index is outside the bounds of the slice, it should return one empty slice and one slice of everything. Whether this is the left or right depends on the index value. See test cases for clarification. So yeah, if we choose an index that is greater than what is in the slice, then we should just return everything to the left. And if we choose an index that is less than the first index, which is a negative value, then it should just return everything to the right. And that way we don't have to worry about returning an error value. We can just make it work with whatever inputs come in. So this is an example of eliminating the need for an error value. If you can make the logic in your program work without having to have this like extra value that indicates an error case, then that kind of simplifies things because then you don't have to do an error check. So that's what we're doing here is we're just making it extra safe and not have to worry about an error case. So anybody want to take a crack at this? Like Lucas, do you want to keep going with that?
I'd be happy to, unless John, you unmuted first, so feel free.
Popcorn John.
I'll rock it out. I was just going to do like a if length of S is less than equal to I. We want to return the left side as being the full array of S and nil. And then we'd want the opposite as well. So we'd want another one that just goes, if it's greater than or equal to I, return nil and S.
Okay, let's see, let's run that. Okay, so splitting the single element by index 2 yielded left 1 and right nothing. And then splitting left index by negative 1 yielded left nothing and right 1. That looks correct. We still failed. Where's the failure? Oh, this one doesn't match. So this looks like there was a regression on something that previously passed. So in this case, 1, 2, 3, by splitting 1, 2, 3 by index 1 yielded left empty and right 1, 2, 3. And that's not what we want because index 1 is this middle value, right? So we wanted it to be 1 and 3. So I'm looking at this case right here. So this new introduced logic, it works for that weird case, but it doesn't work here. So why is that not working?
We
Because
need
that
to
if statement is ahead of the rest of our logic that did the proper, appropriate splitting.
I think the problem with one of the ifs is that it should be 0, not ln s.
You're talking about this one right here where we're dealing with the negative ones.
Yeah. If I is less than 0, I guess.
If I is less than 0. Okay, yeah, because we don't actually care about the length of the, all we care about is that it's negative because the first index is always going to be 0. That's a constant. So we don't have to actually check the length of the slice in this weird case that someone provides a negative index. So let's go ahead and select this. So if I is less than 0, let's try that. And then we get a passing test. Super easy, right? It only took us like, how long? What's the timer at? We got 30 minutes. I don't know if we're going to make it through the whole thing today. This stuff is not easy, by the way, because like you don't have to worry about slice arithmetic on a regular basis. Usually you're not dealing with stuff like that. And when you do, you're very careful and you do very little of it. All this is like slice arithmetic. So you have to be really careful and you have to have a lot of test cases to make sure that you feel safe that you did everything correctly. And if you want to get, if you want to see something that'll blow your mind a little bit, take a look at slice tricks for Go. This is one of the worst things about Go, and this is kind of a problem with generics. If you look through how you do very common basic container type operations that like in a language like Python or Ruby would be nothing, here in Go, it's just really crazy pointer arithmetic, or not pointer, slice arithmetic, where you got to take like the index and you got to take the value that comes from here and, you know, the number of bytes or whatever gets copied here. And, you know, if you want to use it like a queue, do push and pops, you got to remember these little bits here. So these are things that I have to look up all the time. It's a little convoluted, and if we had some good generic support, I think it would fix a lot of these. But yeah, this stuff's not easy. All right, so
So I had a question about what you said before in terms of avoiding error cases. I'm curious if this is like more of an idiotic Go approach, or if that is more of a general programming comment, because where you're like avoiding, I would expect if I'm trying to do a slice and I pass a negative value to a slice, it would either wrap around based on, I guess, just experience with other languages or just error out. And so is there is there a more of a Go approach to that in terms of like error handling and preferring to throw an error for exceptional handling, or should it?
So when you're accessing a slice index, I believe that Go does not allow negative values. It doesn't want you to do stuff like that, like inherently a part of the language. If you want that to be a part of your program, then you have to provide it like we just did, where we have, you know, the explicit check for that negative value, and we you know, perform the additional logic to either do a wraparound or to do the, you know, select everything to the right. So you don't get that out of the box. Your first question about, you know, is this something that is in all languages? Yeah, it is. Like if you have another language where you throw exceptions, ideally you want to write code where you don't throw any exceptions, and if you do, you handle them as low and close to where the problem arised as possible, right? You want to handle an exception as close to where it was thrown, where you have better context of what the problem is, and so that it doesn't bubble up to the ultimate caller, right? So yeah, this is not a Go unique thing. What is Go unique is not having the error in the parameter list, the return values. So that's the only real specific Go thing about this, is how we actually annotate it to say, you know, this function does not return an error. You can provide any input and you should expect it to return safely. So that's just how it's written in Go, but it's a universal concept across, you know, any programming language, is that if you write code that can handle any input without running into some weird error case, that is more ideal than having an error case that the caller has to then handle. So yeah, you're right on that. Regarding the wraparound thing, I'm pretty sure we can't do that. Go is pretty strict about that for a reason. They want to make sure that you're doing things explicitly. I think you can find that in the Go spec, like what is a valid index for the start and ending. You can omit the ending. You can provide up to the end of a slice, but I think if you go beyond it, it's going to complain like we saw earlier. Any other questions?
Nope.
Other than this, how are you splitting your screen like that?
It's just built into Mac. You just do you just do full screen, and then you drag another full screen app into it, and then it has this little divider thing that you can go back and forth.
Okay, wow. Cool.
Yeah, if you have an iPad, you can do even more splits. Like, it's all built in. You can have like an app slide in, whatever. You have a bunch of different things. But yeah, Mac's a little behind the times when it comes to the other Apple stuff.
Yeah, all right. Anyway, sorry about that. Carry on.
No worries. I have another program called Magnet that will do like the Windows type attaching to the screen and splitting it in half and stuff, or putting it in the corner and doing a quarter of the screen automatically. That's another thing if you don't want to use this, because this only does 2 apps at a time. Okay, so let's take a look at the other problem. I think we still have some time. Let's try to do like maybe 10 or 15 more minutes, and then if anybody has anything they want to talk about Go in general and talk about the next topic, we can do that. So we did the split slice. The next step was the recursive split. So for binary search, there's 2 ways you can solve the problem. You can do an iterative approach where you do everything in one function, or you can do a recursive approach where you continually call the same function over and over again with a smaller problem each time until you get to the solution. So the recursive split is just to introduce recursion in Go so that you can get comfortable with it in preparation for the binary search. So what we've got here for the setup is that we've got a side being indicated using the Go equivalent of an enumeration. So if you're not familiar with enumerations, what an enumeration is a bunch of, it's basically a set of constant values that won't change throughout your program, and you can use that to indicate like a set of finite things. So in this case, we have a set of sides. So side really under the covers is just an integer, and we have constant values of that type side that are 0, or actually, sorry, this is 1 and 2. So when you see iota inside of a block, like a constant block, what the iota is saying is start with 0, and then for every successive element, increment by 1. So if it's first 0, then that means if you add 1 to it, it's going to be 1. This is a little confusing, but it's kind of a standard thing in Go. If you look at enums and constants and stuff, they use this all the time throughout the standard library. So I would just recommend looking at other examples of how people do it. But essentially, this is 1. This is value 2. So anybody have any questions about that? Okay. So then the next thing we have is we have, for each side, it's also going to have a string function. This is just purely for debugging purposes. So if you want to print what side you're looking at, instead of it printing out 1 or 2, it's going to print out left or right. So that's just handy if you want to print the problem out and kind of understand where you're getting stuck. It's always good to have good logging mechanisms in your program to figure out where you're screwing up. This right here is, we have a type called nextside. And nextside is just really an alias for a function that returns a side. So that's what this is saying. We have a type that is really the same thing as a function that returns a side. So what we're going to do is in the problem, the code that we're going to fill the implementation for, the test is going to provide to us a function, and we don't know how this function is going to behave. Like it could be behaving randomly, it could have a script, which is actually what it's doing, or it could be, you know, receiving input over the network or blah, blah, blah. It could be anything. All we know is that we're receiving a function, and that function is going to tell us what direction we need to go in the test in order to succeed correctly. And I'll show you how that works. And then here's the actual function that we're going to be working on, R split slice. I named it R split slice because the R is for recursive. So when you see that R there, that's what it means. So we're going to have a slice provided to us of integers. And then we're going to get a function that we're going to repeatedly call to figure out what direction we go next. So this is to simulate decision making in an algorithm. So in the binary search algorithm, the decision making is decided by you looking at the element that you inspected, the middle element, and you say, okay, I either need to go left or go right. So you're making the decision. In this test case, we're kind of eliminating that logic so that we can just focus on the recursive aspect. So this function is going to tell us what direction we want to go.
So, sorry, Paul.
Go ahead.
Question. Is this basically a function pointer, or are there also function pointers in addition to passing? Is this like pass the function by value essentially? And,
yeah, it's a function pointer. Yeah.
Okay.
So in Go we have first class functions. You can pass around functions like values.
Okay. And would you ever pass a function by reference, or is it just makes sense to do it as a value, or is it a reference type in the first place?
It's a reference type, so it's always
Okay.
by pointer.
Okay.
Yeah.
Got it.
So, and a funny thing about pointers, and this is a limitation of the Go runtime, you cannot compare function pointers. The Go runtime will not let you do it. So if you try to, if you want to check if two functions are equal, that will not work. And that's kind of an optimization because I guess it's very hard to do in practice.
I guess if you inlined it one place and not another or something like that, it'd get hard.
Yeah, it's probably something like that. Okay, cool. I'm going to open up this function. Let's see here, recursive split.go. And okay, so does anybody want to take a crack at this, like what we're going to be doing here? So the next side is the key to this. The next side is going to tell us, oh, actually, let me read the directions a little bit more so we know what we're trying to do here. So R split slice recursively splits a slice in the specified direction until there's only one element remaining. You will determine the proper direction to split the slice by calling the provided function ns. So before we can go left or right, we have to split it, right? Like there is no left or right when we have one thing. So we're going to cut the slice in half, and then we're going to operate on either the left or right side based on what that function tells us. So the first thing I'm going to do is cut it in half. And we should know how to do that because that's what we did last time. This time it doesn't tell us to split around an index though, so that's probably an oversight, but let me pull up the test cases. So if we have a 2-element list and we say go left, we're going to get the 1 value. So this is a pretty simple case of splitting. So and what I mean by that is that we did a complicated case just for fun. So we're going to have a left and a right slice, and the left side is going to be from 0 to the length of s divided by 2. And then the other value is going to be from length of s divided by 2 to the end of the slice, like that. So we're going to call, we're going to get our direction from this function ns. We're just going to call it like that. That's it. We don't know how it actually works. That's actually defined by the test. But we don't, for our case, we don't need to know how it actually behaves. We just know that it's going to return the same set of directions every time in this test. So we get the direction, and if the direction is, actually let's use a switch statement here just to be a little fancy. If the direction is left, we're going to return the left. But we got to do this recursively. So we're going to say, if it's left, return our split slice of left. And then we provide the same callback to the recursive. If it's right, we're going to do return r split slice right ns. So the big thing that before I run this test is I want to make sure that this will eventually stop. Because if you have a recursive function and you don't have a way for it to stop, it's just going to keep recursing over and over again infinitely until you run out of stack space, and then the whole program crashes. So what is our base case, and where can we put that in this function?
Be if len is 1, right? Sorry, go ahead.
Yeah, if the length is 1. So we wanna put a check somewhere for this base case.
On the top line.
Or if it's less than or equal to 1, just equal to 1. Let's do that just to be simple. Okay, so if it's equal to 1, we're just going to return that value. Okay, so the idea is that we're splitting, 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 and then eventually we have one element, and that's when we return. And I don't think we need to have this case. That'll never run. Anything else look funny about this function?
I guess constants should be from the uppercase letter, left and right.
Oh, there you go. Good catch.
No, not here, but below.
Below. Oh, yeah, because this is a instance. Okay. There we go. Yeah, that would have failed. Okay, anything else? Okay, let's see if this actually works. I'd be surprised if it works the first time. Let's pull up our test function over here. Where is it? So we can run a focus test. I don't remember where I put that. Here we go. Oh, actually, no, sorry, it's over here. Okay, so we're gonna run this right here. Okay, so we got a fail returning into missing return it into function on 55. Okay. So it does want a return here, which is funny because I thought, oh, if I had a default case, it would have handled it. Okay, so in the case that it's going to return the 0 value.
Or we can just substitute right for the default case.
We can substitute what?
Case right for the default.
Oh, okay. Yeah, if we just used a simple if statement. Yeah, I got too fancy there, huh? Yeah, let's do that. So instead of this, we'll just do an if statement. If left, if direction. And then else we'll just have the right. And that should simplify it quite a bit. There we go. Oh, worked the first time. Well, the second time, technically. Oh, no test to run. I ran it incorrectly. So there's a typo here. Okay, so it says test recursive split in the name right here. And the name of the actual function is test rsplit slice. That's why it's failing. It's not running correctly. So it's a false positive. Why is that still succeeding? I don't expect that to succeed, or at least that quietly. No right since last change. Okay. I'm going to do it verbose so that we can see all of the logs here. Man, that's scary. It worked the first time. Is anybody else scared right now?
You're a senior developer, Paul. Of course.
I don't feel like, I feel like a child. Who put me in charge? Yeah, I guess it just worked. We did it. Cool. I don't think we're gonna have enough time to do the actual binary search, so I'll just save that for next week. I wanted to save a little bit of time to hear what kind of concurrency problems people are interested in for a problem. I just wanted to pick like maybe one problem, and then we could try live coding it after we finish up the binary search. Anybody have anything that was on their mind regarding concurrency? And by the way, I just picked up this book. So if anyone had any ideas from this book, I just got it yesterday, so I haven't read it yet. But if you have any ideas from this book or have not purchased it, it's been recommended by a number of people in the company. So we can definitely pick something from here or pick a chapter and create a problem around that. Anybody want to jump in there?
Maybe we could do something like parallelizing some kind of parsing. Like, I don't know if a sax parser would be like way more complex than we want to get into, but
yeah, ideally you want to reduce the amount of moving parts so that the emphasis is on the actual concurrency aspect, so that anyone who doesn't know anything about parsing or we want a very simple parser, right? We want something that anyone who's new to Go can pick up pretty easily within the course of a 1 hour study session, right?
What about, oh, sorry, go ahead.
I was just going to say it might be easy just to use like sleeps and just, create the necessary channels for Go routines and then come back in with a specific order or something to that effect, if that makes sense.
Yeah, I think that's a good idea, is to just kind of abstract away what actual work is being done, just so that we're focused on the coordination of that work, not the actual work itself. Because with concurrency, there's two problems going on: the actual work being done and how you coordinate that. We just want to focus on one of them. Yeah, so I think simulating the work is the nicest thing to keep the test code and the implementation code clean, so that someone can look at the full thing and get a total understanding of what's going on. If we have to bring in a lot of external libraries to do complex stuff, it'll be harder for someone new to Go to understand it. But that being said, it would also be cool to do some real world stuff, like bring in a web server or do something over the network. That would also be cool. But I think as a first problem, it would be really nice to keep it as simple as possible. So yeah, simulated work sounds good. We can create a simulated parsing type problem situation that could work. Any other ideas?
I would love to see the difference between the Go routines where you're waiting on specific work and then creating like some sort of report or something, or whether you're firing off a bunch of Go routines and you don't care about the order, you just care about, providing the results as quickly as possible. Because I think those are two completely different methods of operating on coroutines.
So if I understand correctly, you want to see a divide and conquer type problem where results are joined at the end and
Yeah.
in no particular order.
Yeah. And then the opposite of where you do care about order.
Okay, cool. Anyone else? Cool. I'll add these discussion points. I have an issue open for concurrency problems, so I'll write some notes on there, and when I have a free moment, just like everyone else, I don't have many free moments. I'll try to think of what would be a good problem to involve these different ideas. Did anybody have anything just Go related they want to talk about, not necessarily related to the study group or anything you wanted to say or ask anyone else here?
So in that test file where you kind of have like a test matrix that you kind of build up and then run all together, is that if one fails, do any of the others run, or is there a better way to kind of get an idea of, I think that makes it hard to find out which condition failed. So you kind of have to like trace it back to one of the definitions or logging.
Yeah, so the way this specific test, the R split slice, it will actually continue to run if the error was caused by your function's outputs. And I'll explain that. So what we're doing here is we get the value that the function returned, whether that value was 1 or 4 or 3, that value is returned here. Then we compare that against what we actually want. We want 3, we want 4 in this case, we want 1 in this case. And then if it doesn't match, what we do is we call error. So error will continue running the test until the test is done. If I would have put fatal, like you have over here, that immediately stops the test. So what we're going to have if we had a single failure is we would have had this this error message logged in the test, and then it would continue to the next case. So that does what you're talking about, where it's not going to interrupt the other test cases so that you can't inspect those and make sure that you're right about some assumptions and wrong about the others. So yeah, that's an important thing to do. The reason why I use fatal here is that if this ever fails, this nextside, then that means there's a problem with the test setup and not really the implementation under test. And so that's why I put a fatal here. I wanted to make sure that this wasn't causing problems that allowed the user to think that the setup was correct. I think that's why I put it there. I don't really remember, actually, to be honest.
So earlier you had a test that failed and you were tracing back to figure out which test case it was that had failed. This was in the prior example, not the R split case. How did you determine which one actually failed? Because in my mind, I would think like adding an attribute of like a name and then outputting that name in the error F would be helpful. But you have not done so, and I saw you try to figure out which test case failed. And
yeah, I think that was this test case or something similar to this where we had a panic. What I was doing was I was trying to look at the panic trace here because it gives you these line numbers on where the panic occurred. So you can see here it's got line 27, line 52. So I was looking at the corresponding code in that. Let me copy this really quick so I don't lose it. And then I'll go over here. So I think, okay, I got to go to the other one. Sorry, I need to go to the test. So I was looking at these traces over here. So it says split slice.go line 27, split slice test at line 52. So I was trying to look at where that panic occurred. That panic occurred during the function where we wrote the panic. We wrote the error. So I looked at that first to see if that provided any information, and it didn't. And then I realized that the panic is causing the test to stop proceeding because we don't recover from that panic. That panic is causing the whole thing to just crash. So I just looked at how many test cases actually ran before the panic occurred. And so I see here I have 1, 2, 3, 4 successful test cases, and then I have a fifth one. So there's a better way to do this. In Go, there are subtests that you can do. So each one of these could have been a subtest, and a subtest gets its own name, and if anything fails in it, it's not going to cause the other ones to crash. So if we would have used a subtest, it would have only panicked that specific test case, and the other ones would have been able to proceed. So that's just because these tests are simpler than they should be. They should probably have the subtests built in. And just to show you what that would look like,
I think this would be a good challenge to see in the next problem that we work on. Subtesting specifically. Yeah,
I think that would be good. We'll definitely incorporate that next time. I think Steve put in subtests for one of, actually, yeah, he did. Let me pull up one of the tests that he wrote for binary search.
Because it's really nice in RSpec, you have like the output tells you which test failed, whereas here,
I mean, you do run into this kind of ambiguity when you use like shared examples in RSpec, where it's just kind of, if you can add a name to it for a description to give you more idea, but you still run into this where it's like which of these setups.
Yeah, so the Go convention is that it takes the name of the test. So the name of the test is test search. And then when you call t.run, you provide a string that identifies that subtest. So what it takes the name of the function, adds a slash, and then it puts in that string. And so you can actually focus on a specific subtest if you specify that string. So if you saw how I was running the test, I have -run equals as an argument, and that's where I'm providing the focus test. So I can focus in on that specific subtest that way. So the issue of shared variables, yeah, that's a big issue. Ideally, what you do is you have like one big struct where you have like each instance of that struct is like isolated, so that when you run that test, you're only operating on that value. But yeah, sometimes you can't do that if you've got some like helper function, or you have something expensive. Like I know in the Gitly code base, we're like creating repositories and creating and destroying them a lot, and sometimes they're created once in one location and then copied somewhere else, so you don't have to clone it over and over again. And there's some shared state there, but we have like helper scripts to help with that, so there's a little complexity added in. But yeah, there's that's something you should always worry about, is contaminating tests. But yeah, this is what it looks like. You just call this little closure wrapper right here. So you provide your test as a closure right here, and then it runs it. So if a panic occurs in here, it's only going to cause this subtest to fail. That's how that works. So we'll definitely use that in the next one. I'll put a note here. I think the reason why I didn't use subtests is because you have to provide a name, and some of these are just numbers, so I couldn't really think of a good name to give them. Because if you don't provide a name,
test one.
You could do that. Yeah, you could just number them. You could definitely use an index, but I guess I thought about it a little bit too much before I pulled the trigger on it. Any other questions? Okay, cool. I think we just passed time. Thanks everyone for joining. I'll follow up on that concurrency issue and try to take a shot at that binary search, and we'll try to wrap that up next time. Take it easy, everyone. Thank you.